Hello. Here at the Brick Squad Research Rehabilitation Center, we aim to treat and heal the underlying causes of knee injuries. Let's face it, knee injuries can happen anywhere. In the stairwell, perhaps. Walking to class. High-fiving a friend.
Yeah!
Sitting on a bench.
Our latest innovative study has proven the effectiveness of an exercise known as the depth jump with the addition of a TheraBand. Here is what our researchers have to say.
We hypothesized that the depth jump in conjunction with the TheraBand will encourage subjects to redistribute more weight onto the injured leg. Our hope is that the introduction of the TheraBand will promote a shift in the patient's center of pressure, thus facilitating a speedy and healthy recovery. Since there will be a controlled trial followed by an experimental trial for each subject, and since we have a hunch at which the direction the data would lie, we determined that a one-tailed paired t-test would be the most appropriate significance testing.
Using G-Power, we calculated that our study required a minimum sample size of 9 subjects. In order to test our hypothesis, we recruited 17 volunteers from the Georgia Institute of Technology's Biomedical Engineering Department, specifically those enrolled in BMed 3110. To perform the experiment, we used a silver super heavy TheraBand, 2 Wii boards stacked on top of each other to make a 4-inch step, a Nintendo Wii balance board, a program entitled LabVIEW, and a force gauge. For each participant, we first determined which leg was his or her dominant leg by simply nudging the subject off balance and observing with which foot the subjects caught themselves. Subjects were then instructed to stand on the 4-inch step with feet aligned in the designated rectangles. As shown by this participant, subjects lifted their dominant legs in front of them just enough to no longer be weight-bearing. When prompted, subjects jumped from the step onto the Wii balance board with both feet standing simultaneously and instantly performed a squat to 90 degrees. For the experimental trial, subjects repeated the same process, except this time a Brick Squad research assistant secured a TheraBand around the subject's waist and supplied 8 pounds of force as measured by the force gauge in a direction opposite from the subject's dominant legs. For each jump, the average X location over the time spent on the Wii board was recorded. Subjects performed each trial 3 times, 3 control jumps, 3 experimental jumps. The 3 average X and Y positions from both trials were then averaged again. In conclusion, we anticipated a change in weight distribution in a lateral direction, considering this redistribution was the entire goal of the exercise, to encourage rehabilitating subjects to trust their injured limb with more weight. The table shown represents the mean center of pressure and standard error in the X direction for every subject that was right foot dominant. Each patient has a value for the control settings and a value for the experimental settings. Similarly, this table represents the same data for those subjects who are left foot dominant. With the exception of subject 1, we found a significant difference in the center of pressure for every subject. Right foot dominant patients showed a significant shift in center of pressure to the left, while the left foot dominant individuals showed a significant shift in pressure to the right. We have once again displayed the effectiveness of our research here at Brick Squad Rehabilitation Research Center. We have confirmed the effectiveness of using a TheraBand while performing a depth jump to encourage subjects to shift their center of pressure toward their injured leg. Through this experiment, we have proven the usefulness of Wii balance boards in rehabilitation-related testing. In the future, we aim to perform experiments to find the optimal force applied by the TheraBand for ideal weight distribution. At last, we have given people hope for an injury-free future.